Assalamualaikum everyone. Today we are going to discuss about chapter 5, which is X-ray diffraction technique, code PHY370. So, learning outcome. At the end of the chapter, students should be able to explain the concept of first, diffraction of X-ray phenomena, second, X-ray sources, third, X-ray diffraction and Bragg's law, calculation of d-spacing, and the last one, cubic crystal structure determination. 5.1 X-ray diffraction technique. And we will discuss about first subtopic, which is 5.1.1 phenomena of diffraction. First, what is diffraction? So diffraction is a wave phenomenon in which the apparent bending and spreading of wave when they meet an obstruction. Diffractions occur with electromagnetic wave such as light and radio wave, and also in sound wave and water wave. Light diffraction is caused by light bending around the edge of an object. The interference pattern of bright and dark lines from the diffraction experiment can only be explained by the additive nature of wave. Wave peak can add together to make a brighter light, or a peak and a through will cancel each other out and result in darkness. From this figure, we can see the diffraction pattern, which is light is coming from the left, and they create the pattern just like the ring pattern. Okay. So, constructive interference and destructive interference. What is the constructive interference? Constructive interference is the result of synchronized light waves that add together to increase the light intensity. And destructive interference results when two out of phase light waves cancel each other out, resulting in darkness. From the pictures left side, we can see the constructive interference, which is sum of two waves. The resultant is more than from the first light wave and second light wave. And from the right figure, which is destructive interference pictures, the sum of the two waves, which is the black line, is less than the first light wave and second light wave together. So 5.1 to X-ray sources. X-ray properties. Invisible, highly penetration electromagnetic radiation of much shorter wavelength, which is higher frequency than visible light. The wavelength range for X-ray is from about 10 power negative 8 meter to about 10 power negative 11 meter. The corresponding frequency range is from about 3 times 10 power 16 Hz to about 3 times 10 power 19 Hz. From this figure, we can see that there's the range of the X-rays and the frequency of the X-ray. Okay, X-ray sources. Now we already discussed about the characteristic of the X-ray, and we can see the production of X-rays. How to produce X-ray? Visible light, photon, and X-ray photons are both produced by the movement of electrons in atom. Electrons occupy different energy level or orbitals around an atom nucleus. When an electron drops to a lower orbital, it needs to release some energy. It releases the extra energy in the form of a photon. The energy level of the photon depends on how far the electron drops between orbitals. From this diagram, we can see that as a particle is come in, and they will produce a photon. X-ray can be produced in a highly evacuated glass bulb called an X-ray tube that contain essentially two electrodes and anodes made of platinum, tungsten, or another heavy metal of high melting point and a cathode. When a high voltage is applied between the electrode, stream of electrons, which is cathode rays, are accelerated from the cathode to the anode and produce X-ray as they strike the anode. You can see from the diagram. X-ray diffraction and Bragg's law. Diffraction of wave by crystal. The diffraction depends on the crystal structure and on the wavelength. When the wavelength of the radiation is comparable with or smaller than the lattice constant, one can find diffracted beam in direction quite different from the incident radiation. The structure of a crystal can be determined by studying the diffraction pattern of a beam of radiation incident on the crystal. Beam diffraction takes place only in certain specific direction. By measuring the direction of the diffraction and the corresponding intensities, one obtains information concerning the crystal structure responsible for diffraction. X-ray crystallography is a technique in crystallography in which the pattern produced by the diffraction of X-ray through the closely spaced lattice of atoms in a crystal. Bragg's law identifies the angle of the incident radiation relative to the lattice plane for which diffraction peaks occurs. Bragg derived the condition for constructive interference of the X-rays scattered from a set of parallel lattice planes. W.L. Bragg considered crystal to be made up of parallel plane of atoms. Incident waves are reflected specularly from parallel planes of atoms in the crystal, with each plane is reflecting only a very small fraction of the radiation, like a lightly silvered mirror. From the pictures, we can see the reflection, the angle of incident is equal to the angle of reflection, which is same with the characteristic of the light. Bragg equation, which is 2d sine theta equal to n lambda, where d is spacing of the plane and n is the order of the diffraction. Bragg reflection can only occur for wavelength n lambda less than 2d, which is spacing of the plane. Scattering of X-ray from adjacent lattice point A and B from the figure. Now we are going to calculate of the D spacing. There will be constructive interference of the wave scattered from the two successive lattice points A and B in the plane if the distance AC and dB are equal. So, labeling the reflection plane. To label the reflection, Miller index of the plane can be used. A beam corresponding to a value of n more than 1 could be identified by a statement such as the nth order reflection from the HKL plane. NH, NK, and L reflection. Third order reflection from 1, 1, 1 plane, which is we can 3, 3, 3 reflection. Cubic crystal structure determination, nth order diffraction of HKL plane. Rewriting the Bragg's law. So 2d sine theta equal to n lambda now become 2d over n sine theta equal to lambda, which is make the nth order diffraction of HKL plane of spacing d looks like first order diffraction of plane of spacing d over n. Planes of this reduced spacing would have Miller index NH, NK, and NL. N is an integer and the order of the reflection. For Cooper K alpha radiation, which is lambda around 1.54 Armstrong and D lattice 110 2.22 Armstrong. So n sine theta n theta. Number 1, n equal to 1. And then we got the result 0.34 sin theta, theta 20.7. First order reflection from 110. N2 sin theta equal to 0.69 and angle become 43.92 degrees. Second order reflection from 110, also written as 220 plane. Now we got the new formula for DHKL, which is A over H square plus K square plus L square and Z. D220 will become A over Z A. D110 will equal to A over Z2, which is this H and K and L and 2 power 2 and plus 2 power 2 and plus 0. So we got the Z2. If we divided D220 D110, we got 1 over 2. In HRD's order reflection from HKL is considered as first order reflection from NH, NK, and L. N lambda equal to 2D sin theta, lambda equal to 2D over N sin theta, lambda equal to 2D NH, NK, and L sin theta. Summary. Quiz 1. Sample of BCC metal was placed in an X-ray diffractometer HRD using X-ray with a wavelength of lambda. Diffraction from the plane 110 was obtained at 2 theta for 4.0704. Calculate the value of the lattice constant for this BBC elemental metal. Assume first order diffraction n equal to 1. We just assume the first order. Okay, from this equation, 2d sin theta equal to n lambda. So d, we got a over h square plus k square plus l square. Then because of the plane 110, so we just put a 1 and 0. So we got a equal to 2.865 10 power negative 10 meter. And we put the from the equation d 2 theta divide for 4.704, we divide by 2, we got the theta. Okay, 1 and lambda already given. Okay, second quiz. X-ray of unknown wavelength are diffracted by the silver sample. The 2 theta angle was, I think, 1994. Then we already know we must divide it by 2. Okay, for the plane 200, what's the wavelength of the X-ray used? The lattice constant silver is already given. Okay, so what should we do? So we should find the D. Okay, we're going to find the lambda. Okay, just put the plane 200. We got 2 power 2 and Z, we cancel, and we got lambda equal to 2.810 power negative 10. Okay, so that's all.